Assignment problem, Hungarian method. So in this video, we are going to see about the assignment problem, particularly Hungarian method. The assignment problem means assignment problem is a particular case of transportation problem where the objective is to assign a number of resources to an equal number of activities so as to minimize total cost or maximize total profit of allocation. The problem of assignment arises because available resources such as men, machines, etc. have varying degrees of efficiency for performing different activities. Therefore, cost, profit or loss of performing the different activities is different. The problem is to find an assignment, which job should be assigned to which person one-on-one basis, so that the total cost of performing all jobs is minimum. Probably this kind are known as assignment problem. Thus, the problem is how should the assignment be made so as to optimize the given objective. Some of the problem where the assignment technique may be useful are assignment of workers to machines, salesmen to different sales areas. Now the mathematical formulation of the assignment problem. Mathematically, an assignment problem can be stated as follows. Minimize the total cost. Is it equal to sigma I equal to 1 to n, sigma j equal to 1 to n, Cij into Xij, where Xij equal to 1 if ith person is assigned to the jth job and Xij equal to 0 if ith person is that assigned to the jth job. Subject to the constraints sigma I equal to 1 to n, Xij equal to 1 for j equal to 1 to n, which means that only one job is done by the ith person. Sigma j equal to 1 to n, Xij equal to 1 for I equal to 1 to etc. n, which means that only one person should be assigned to the jth job. Now the Hungarian method. The Hungarian method of assignment provides with an efficient method of finding the optimal solution without having to make a direct comparison of every solution. It works on the principle of reducing the given cost matrix to a matrix of opportunity cost. Opportunity costs show the relative penalties associated with assigning resources to an activity as opposed to making the best cost assignment. Opportunity costs show the relative penalties associated with assigning resources to an activity as opposed to making the best or least cost assignment. If we can reduce the cost matrix to the extent of having at least one zero in each row and column, it will be possible to make optimal assignment. Now, the working rule for solving the assignment problem using Hungarian method. In step 1, first we have to develop the cost table from the given problem. Step 2, find the opportunity cost table, that is, first locate the smallest element in each row of the given cost table and then subtract that from each element of that row. And in this case, we have at least one zero in each row. If it is not found, then in the above reduced matrix, locate the smallest element in each column and then subtract that from each element. So finally, each row and column now have at least one zero value. So step 3, make assignment in the opportunity cost matrix by using the following procedure. Now examine rows successively until a row with exactly one unmarked zero is obtained. Make an assignment single zero by making a square around it. For each zero value that becomes assigned, eliminate all other zeros in the same row and column. Repeat the above two steps for each column also with exactly single zero value all that has not been assigned. If a row or column has two or more unmarked zeros and one cannot be chosen by inspection, then choose the assigned zero cell arbitrarily. Continue this process until all zeros in row and column are either enclosed or strike off. Now step 4, optimality criterion. So if the number of assigned cells is equal to the numbers of rows and columns, then it is optimal solution. The total cost associated with this solution is obtained by adding original cost figures in the occupied cells. If a zero cell was chosen arbitrarily in step 3, there exists an alternative optimal solution. But if no optimal solution is found, then go to next step. So in the step 5, revise the opportunity cost table. So by drawing a set of horizontal and vertical lines to cover all the zeros in the revised cost table obtained from step 3 by using the following procedure. The procedure of making assignment. For each row in which no assignment was made, mark as a tick. Examine the marked rows. If any zero occurs in those columns, tick the respective rows that contains those assigned zeros. Repeat this process until no more rows or columns can be marked. Draw a straight line through each marked column and each unmarked row. If a number of lines drawn is equal to the number of columns, the current solution is optimal solution. Otherwise, we have to go to the next step 6. So step 6, develop the new revised opportunity cost table. So from among the cells not covered by any line, choose the smallest element, call this value k. Subtract k from every element in the cell not covered by line. Add k to every element in the cell covered by two lines. That is intersection of two lines. So elements in cells covered by one line remain unchanged. So step 7, repeat step 3 to 6 until an optimal solution is